Okay, hello everyone. Guys, I'm going to go over this practice test, number 2. All right, this first one, I have to go kind of fast here, okay? This first one, you're going to match up these sampling methods. All right, you need to remember what they are. First one, find the average height. You measure the height of people on your bus. All right, that's convenience. That's close to you, something too easy. All right, you want to measure the whole city, not just people on your bus. All right, teachers are asked to participate in the study. At the school selected, every teacher from that school participates. All right, that's cluster sampling. Number 3, participants volunteer. Volunteer. Self-selected. All right, look for that word, volunteer. Number 4, population group by state, then a random sample chosen from each state. Random sample from each group. That's stratified. And this one, every 9th phone number, that's a rule. A rule is systematic sampling, okay? Guys, the next one are through the 3 types of studies, all right? Researchers watch teenagers through a 2-way mirror. They're watching, observational. Political party takes a poll. They call people up and ask them a question. That's a sample survey. A farmer gives one field of crop a fertilizer and sees what effect it has. Again, you give something a treatment and see the effect it has, experiment. And you compare it to the original normal yield. That's the control group. All right, number 3, we're talking about a normal distribution. It's got a mean of 32 and a standard deviation of 7. So again, I set up my little thing here. 32 is the middle, up 7, down 7. Remember the percentages, 34, and this is 13 and a half, 2 and a half. Remember the percentages. What percent of data falls within the interval 25 to 39 is right here. Add these 2 up. All right, it's 68. Normal distribution, mean of 89, standard deviation of 5. Again, I set this up, 89. I go up 5, down 5, down 5. Put the percentages in here. These are the only ones you need right here. Because they're saying what percent of data falls below 94. That's starting right here at 94 and everything down here. So take these 4 and add them up. 34 plus 34 plus 13 and a half plus 2 and a half. That's 84%. All right? That's 34% higher than 50. All right? 84. All right, standard deviation normally distributed. The value that is 1 standard deviation above the mean is 68. So here's the mean. 1 above is 68. The value that is 2 below, 2 standard deviations below, is 35. So here's the mean. This is the mean. Right there. So go down 1, 2, 35. So 68 to 35, I subtracted them. The difference was 33. So I divide that by 3. So each of these is an increment of 11. Each of these is an increment of 11. So 68 minus 11 is 57. All right, just take a look at this right here. What's the mean? The mean is right here, 150. That's the mean. Take this and drag it up here, 150. Standard deviation, look, you go up 30, up 30, up 30, down 30, down 30. It's 30. All right? Take a look at the chart. All right, again, this is Miss Burleson. Students in her class. Wants to know the number of minutes they spent doing homework. She found it was normally distributed. It's got a mean of 30. Standard deviation of 10. So here's my little chart here, little graph. 30 is the mean, up 10 to 40, down 10 to 20. All right, what range of time spent doing homework contains 68% of the data closest to the mean? That's the 68 right in here. All right, drag them up there, 20 to 40, 20, between 20 and 40. Okay? Guys, number 8. Again, set of values is a mean of 27, standard deviation of 4. Find the value that has a z-score of 3.5. All right, this is the z-score, but we're looking for the value. This is the formula for the z-score. We're looking for the value. If you solve for value, v, this is the formula. So use this to find v. Z-score times the standard deviation plus the mean. I got 41. Guys, this one, just use the regular z-score formula. The value is 8. The mean is 7.2. The standard deviation is 4. All right, our answer is 2. All right, 3 true statements. Guys, the standard deviation on a standard normal curve, that is the z-score. On a standard normal curve. Remember, this was 0. This was 1, 2. This was -1, -2. That's standard, okay? Negative z-scores mean the value is below the mean, less than the mean. Yep, that's true. The z-score, what is it? It's the number of standard deviations that some value is above or below the mean. That's exactly what it is, okay? Guys, obviously it's none of these, okay? All right, what's wrong with this picture? Yeah, you can't hardly see it here, but on the computer you'll see it's a, I can't really see it here. It's one of these Venn diagrams, all right? 70% plus 60% plus 63%, that's more than 100. That's more than 100. All right? The area is misrepresented because the percentages do not add up to 100%. All right? Guys, on the test, this is probably going to be different. It's going to be a different answer, okay? Be aware of that. All right, guys, 80 shoppers, 52 prefer generic brands. Set up your proportion, divide it. That's the sample proportion, 65%. Margin of error, again, use the formula. The sample size is 156. Take the square root of that. 1 over the square root of 156. It's about 8%, okay? Again, this time we want the sample size. Use this formula right here. Margin of error is 6%. Use 0.06. I got about 278 right there. All right. 1,000 teenagers surveyed, 74% do not plan to stay in their community after finishing their education. All right, first, use the 1,000 to find the margin of error. That's the sample size. The margin of error is plus or minus. I'm going to use 3%. So from 74, go up 3, and 74 go down 3. So this is going from 71 to 77. It's right here. Okay? Last one. What's true? Parameters don't summarize sample. Statistics, population, no. Always accurate, no. Smaller, no. Because samples are an estimate, sample proportions should always be reported with a margin of error. Yes. All right? Statistics summarize data from a sample. Yes. The larger the sample size, the smaller the margin of error. Yes, that's true. Parameters summarize data from a population. Yes, that's true. The larger the sample size, the larger margin of error. No, that's not true. It's these 4, okay? Guys, that's it. If you have any questions, email me. I have to stop the video because I'm running along here. All right, thank you.